In this example, we will solve a system of equations using the elimination method. In the given system, I have three equations, and I'm going to just label them equation 1, 2, and 3. And we are going to go through a series of combining two equations at a time to create a new equation that we can then solve a system of two equations and eventually find out the values for x, y, and z. So the first thing I'm going to do is I'm going to take equation 1 and 2 and I'm going to combine them together using addition, which is also what we call the elimination method. So equation 1 is x plus y plus z equals 9. Equation 2 is x minus y plus 2z equals 1. And if we combine them together through addition, the new equation that we get is x plus x, 2x. The y variables are eliminated, hence the name of the method. And z plus 2z is a positive 3z equals 10. I'm going to do the same process, except the next time I'm going to use equation 2 and 3 and combine them together to create a new two-variable equation. So equation 2 is x minus y plus 2z equals 1. Equation 3 is x plus y minus z equals 5. And when I combine those two together, our new equation becomes 2x. Again, the y variables are eliminated, and 2z minus z is a plus z equals 6. So now I'm going to combine these two equations and solve our system for either x or z. So let's see what we have. If I take 2x plus 3z equals 10, I see that if I take the opposite of this equation, in other words, if I multiply this equation by -1, then I can get the opposite terms, which means that my x variables will eliminate themselves out. So a -1 times 2x becomes -2x, and a z times -1 is minus z, and a 6 times -1 is -6. So when we combine our two equations that contain two variables, we eliminate the x variable. 3z minus z is 2z, and 10 minus 6 is 4. And then we can divide both sides by 2, and now we have solved for z. Therefore, z is 2. And now using back substitution, I can take the value we have found for z, and I can substitute it into either of the equations that contain two variables. It's your choice. So there's no wrong or right way to go. So by just looking at this, I'm just going to arbitrarily choose my second equation that I created with two variables. So we'll take 2x, and where there's a z, I'm going to insert the 2 that we found, equals 6. Subtracting 2 from each side, 2x equals 4. Divide both sides by 2, and we find that x is also 2. So we have solved for 2 of the 3 variables. And then last but not least, now that I have 2 of the 3, I have to go back to one of the original equations in the system. And again, it's arbitrarily your choice. There's no right or wrong on which one you choose. So I'm just going to pick equation 1, and I'm going to replace x with the 2 that we found. We're now looking for y. We found that z was also 2 and set that all equal to 9. And then we're going to solve this equation for y. So 2 plus 2 is 4. So on the left-hand side of the equation, I have y plus 4 equals 9. And then to solve for y, I will subtract 4 from both sides. So y is 5. So the solution that I have found for this system of equations using the elimination method is 2, 5, 2. But as you know, before we walk away from a system, what do we need to do? Yes, we need to check our solution, because this isn't a solution unless it gives me a true statement in all 3 of the equations of my system. So let's use the bottom of the board, and we are going to quickly check our solution in all 3 equations. So in equation 1, if x is 2, if y is 5, and z is 2, does this equal 9? 2 plus 5 is 7, 7 plus 2 is 9. So it checks in equation 1. Now let's see if it checks in equation 2. 2 minus 5 plus 2 times the 2 for z, does this equal 1? Well, 2 minus 5 is negative 3. 2 times 2 is 4. And negative 3 plus 4 is 1. So again, we get a true statement. So we're good so far with 2 of the 3. Now let's check the final and third equation. So we would replace x with 2, y with 5, minus 2, and is this equal to 5? And as you can already see, 2 minus 2 is 0, and this simplifies to 5 equals 5. So now we can definitively say, because our ordered triple 252 made a true statement in all 3 of the original equations, that our solution is 252. And this is how you solve a system of equations using the elimination method.